So let's go back to our consumer and their preferences. And I want to talk about terms of trade, the consumer's terms of trade. And since we're in a two-good world, we only have one good to trade. We can trade good Y for good X. Okay? And we could also trade good X for good Y, but that just makes it unnecessarily confusing. So what we're going to look at is how much Y the consumer is willing to give up to get one more unit of good X. And so we always look at change in X equals 1. So this is 1 unit of good X, and we want to know what is the change in Y. So we have this term in economics called the marginal rate of substitution. The marginal rate of substitution is exactly what we just described here. It's how much Y the consumer is willing to give up to get one more X, one more unit of X. And what was interesting about this point and this point? What must be true there? Well, it must be true that A and B, the consumer was indifferent between A and B. So that means that the consumer is equally satisfied. And so we'll just say, and remain indifferent. Okay? The consumer is on the same indifference curve. It's here at point A and point B. So they're equally satisfied. So the marginal rate of substitution tells us how much Y they're willing to give up to get one more unit of good X. That is the consumer's terms of trade. So now let's break this down a little bit more. Let's dig into a little bit more about what's going on in this graph. Okay? And one thing that we haven't talked about yet is the marginal utility of good X, or the marginal utility of either good X or good Y, but we'll start with good X. Well, what do we know about the concept of marginal utility? Well, that is the change in utility divided by the change in good X, right? So that tells us that if we only changed good X, and we went from here to here in terms of consuming, so instead of going to point B, we went to point C, right? Keep the same Y, and move only good X. So how much additional utility, there's an indifference curve that runs through here, it just makes things messy if I draw it. How much utility is gained by moving up to point C, okay? And that would be the marginal utility. And what's our change in good X? We said that was 1. And so for this one, it's only change in utility. Well, what must be true then about the marginal utility of good X and the marginal utility of good Y when we move from A to B? So let's draw those out. We have the marginal utility of good X looks like this. Or we can rewrite this as the change in the marginal utility of good X is equal to the change in utility is equal to the marginal utility of good X times the change in X. And comparably or similarly for good Y, the change in utility from good Y is equal to the marginal utility of good Y times the change in the number of units of good Y. So we move from A to C and then from C down to B in our path to get from A to B. So we're sort of breaking this down a little bit. Right? So if we wanted to draw this one, we could come back here and say MUY is equal to the change in utility from consuming good Y, right? So what do we know about these two change in utilities moving from A to B? Well, we know that the change in utility from consuming this, one more unit of good X, is offset exactly by the change in utility, the decrease in utility, from consuming this amount less of good Y, right? Because we're on the same indifference curve, right? So this difference, this change in utility has to be equal to this change in utility. So the change in utility of good X, the increase in utility here, is equal to the decrease in utility on good Y, because we're consuming less Y, okay? Well, if these two are equal, then it must be the case that these two sides of the equations are also equal. So MUX times change in X is equal to MUY times change in Y. And now we can continue on and do a little bit more algebra. So we can go MUX times change in X divided by MUY is equal to change in Y. Moving this down, and we can move this one over. So we have MU, and we have a negative sign in here. MUX, MUY is equal to change in Y, change in X. And again, there's a negative sign there. Well, what does change in Y over change in X look like? Well, that's the slope back here. And so going back, what is the slope? That is the derivative of Y with respect to X. And so here we see that the derivative or the slope, or what we call the consumer's terms of trade, is equal to the ratio of the marginal utilities. Okay? So how much Y the consumer is willing to give up to get one more unit of good X and remain equally satisfied is equal to the slope of the indifference curve at a particular point, which is also equal to the ratio of the marginal utility of good X and the marginal utility of good Y.